Hi, I'm Mr. Singer. Hi, I'm still Mr. Singer, even though I look different. Oh, hi there. Even though I look different, I have beautiful hair, I'm still Mr. Singer. Even with this really cool Viking helmet, I'm still Mr. Singer. I'm only doing all this to show you that it's the same thing with decimals and fractions and percents. They're all the same, they just may look different. Got it? So let's look at some examples. Okay, so first of all, let's do like a really easy math problem. Remember when you were a little kid and you'd have a problem like 26 minus 21, right? You know how to do that. You do 6 minus 1 is 5, 2 minus 2 is 0. But when you have a 0 on this in the beginning of the number, you don't really need it. You can leave it off. But if you did leave it there, it wouldn't really matter. It's the same thing. So with decimals, it's sort of the opposite. So if I have a decimal like 0.2, it is the same thing as 0.20 or 0.20. It doesn't matter how many zeros I put over here, it's the same thing. Got it? If I have 4.63, I can add as many zeros on to the end, it doesn't matter. Okay, so if you are presented with something like, what's bigger, 0.2 or 0.19? Well, the reason that I call this 19 and not 19 is because 0.2 is bigger than 0.19, right? So I could put a 0 here, and now it looks like a 20 and it looks like a 19, but I don't really need to do that because when you are comparing decimals, what you do is you look at the first number after the decimal. This one is a 2 and this one is a 9, so that's how I know that 2 is greater than 9, so that one is bigger. 0.2 is greater than 0.19. This is a really important thing that you got to like remember. Okay, so in the same way that I had my different costumes on, my different hairstyles or whatever, and I was still Mr. Singer, it's the same thing with fractions and decimals. Oh, no, I don't want to do that one. Okay, so remember how I had my cool pink hair and the hat and the helmet and whatever? So even though I had different costumes on, I was still the same person, still Mr. Singer. It's the same thing with these numbers. So all of these, even though they look different, they're all actually the same. So the best way that we can compare them is to, well, let's make them all decimals because that makes it a little bit easier. So 0.2 is just 0.2. 20%, you remember that becomes 20 over 100, right? And this 21/100ths is the same as 0.20. And remember, if there's a 0 at the end, we can get rid of it. So this is 0.2 and this is 0.2. And now we have to turn this fraction into a decimal. So if you remember how to do that, we have to divide, right? So this says 1 over 5, which means 1 divided by 5. So I'm going to write 1.0 divided by 5. 5 goes into 1 0 times. We bring up the decimal point. 5 goes into 10 2 times. 2 times 5 is 10. And we're done. So look, these are all 0.2. Got it? Even though they look different up here as a fraction, decimal, and percent, they're all the same. That is an important thing to remember. So one way that you'll need to do this is when we have to put things in order, right? So you'll have problems where you have to say, what's bigger? Or put these in order from smallest to biggest. 1/5, 25%, and 0.23. Well, you think, I don't know, how do you compare 1/5 and 25%? They're totally different kinds of numbers, but what we have to do is convert them so that they are the same kind of number. So for this purpose, let's just put all of these into decimals. It's probably the easiest thing. So 0.23 is still just 0.23. 25%, if you remember, is 25 over 100, which is 25/100ths, which becomes 0.25, right? Or you remember from converting a percent to a decimal, you just go 2 places over, right? And so it's 0.25. And this, what we just did before, you're going to have to convert this into a decimal by doing 1 divided by 5. And we just did actually this exact problem. 1.0 divided by 5, the decimal comes there, 0, 5 goes into 10 2 times. So now we have 0.2, 0.25, 0.23. Okay, so now it's a little bit easier to put them in order. But of these decimals, which is the smallest? Well, 0.2 is the same as 0.20. So now you can think of it as 20, 23, 25. So the smallest one would be 1/5, right, which is 0.20. So this is the smallest, 1/5. And then the next smallest one would be 0.23. And the biggest of these would be 25%. Got it? Great. All right, so one of the things you need to be able to do is to compare fractions. So what's bigger, 1/3 or 1/5? Sometimes you can draw little pictures or imagine a slice, slices of pizza, and you can do it that way. So for this one, let's see. If I have a pizza and I cut it into 3 pieces, right, because it's 1/3, and I color in that much, and then here, this pizza is going to be cut into 5 pieces, and I color in one of these, well, I can see this one looks bigger than this one, so then 1/3 would be greater than 1/5. However, that doesn't work with all the problems, just because if I say it's 17 20-seconds or 23 35ths, you're not going to be able to draw a pizza with all those slices and have it be even and have it look right. So the better way to do this is to make these fractions have the same denominator. It's just like in 5th grade when you had to add fractions with different denominators. It's the same thing. So first thing we have to do is find the common denominator between 3 and 5, meaning what is the smallest number that 3 and 5 both fit into? So I'm going to put that here. Well, 3 goes into 15 and 5 goes into 15. So let's say 15 and 15. 3 times what is 15? Well, 3 times 5 is 15. So then you have to do that up here too. 1 times 5 is 5. So 5/15 is the same as 1/3. Now this time, 5 times 3 is 15. So I have to do 1 times 3 is 3. So that's 3/15. Now it's a lot easier to compare them, right? What's bigger, 5/15 or 3/15? Well, clearly 5/15 is bigger. Piece of cake, right? Let's try another one. All right, so here's another example. We have 3/5 and 4/6. This is a little bit harder to compare, even if you're drawing a picture of it. So let's also with this, we're going to find the common denominator between of these. So what is the smallest number that 5 and 6 both fit into? Well, how about, if you're not sure, you can just do 5 times 6, which is 30. So let's do that. So 30 and 30, right? They both fit into 30. 5 goes into 30. It's 5 times 6 is 30. So then you have to do times 6 up here. 3 times 6 is 18. So 18 over 30 is the same as 3 over 5. And now let's try this one. 6 times 5 is 30. And 4 times 5 is 20. So now you have 18 over 30 and 20 over 30. Okay, so which one is bigger? Now it's easy to compare because it's easy to see that 20 is bigger than 18. So 18 or 3/5 we now know is less than 4/6. Or 18 over 30 is less than 20 over 30. Got it? Let's try one more that's a little bit different. All right, so now there's a couple of different ways we can do this one. There is sort of a shortcut because here we're comparing 7/12 and 1/2. Well, how many 12ths do we know is equal to 1/2? Hopefully you know that 6/12 is equal to 1/2, right? You should know that 6 over 12 is the same as 1/2, right? Because 6 is half of 12. So if 6/12 is the same as 1/2, then 7/12 is obviously a little bit bigger than 1/2. So right off the bat, I could just do 7/12 is greater than 1/2. But if I wanted to convert it so they're both the same denominator, I would make them both of them be 12, right? Because 12 fits into 12 and 2 fits into 12. So this is just 7/12 is equal to 7/12, and 6/12 is equal to 1/2. And so again, 7/12 is greater than 6/12. So that's how you can do this one. Awesome. Okay, now you're also going to have problems that look like this, where you have several fractions and it says put them in order, or you have to put them on a number line, something like that. But how do you compare 4/5 to 3/4 to 9/10? They all look so different. So what we're going to do is we're going to put them all make them all have the same denominator. Now you could also just turn them all into decimals, which basically is having a denominator of 10, but let's just do it like this. So what is the smallest number that 5, 2, 10, and 4 all fit into? Well, this is where knowing your times tables really well comes into play. Well, 5 and 2 both fit into 10, but 4 doesn't fit into 10. What about 20? 5 goes into 20, 2 goes into 20, 10 and 4, they all go into 20. So each of these is going to become something over 20. So it's going to become 20 over 20, 20, 20. Okay, so 4/5, 5 times what is 20? 5 times 4 is 20. 4 times 4 is 16, so that's going to go there. 1/2, well, I just know 10 over 20 is the same as 1/2. 9, okay, well, let's see. 10 times 2 is 20, so 9 times 2 is 18. 4 times 5 is 20. 3 times 5 is 15. Oh my gosh, now it's so easy to put these in order, right? What's the smallest one here? Okay, 10 over 20 is the smallest. So 10 over 20, it's 1/2. 1/2 is the smallest one, right? And then after that comes this one, 3/4, right? Because that's the next smallest one. After 15 over 20, oh, then we have 16 over 20, so now it's 4/5. And the last one is 18 over 20, which is 9/10. So now we just put them in order because we were able to have them all have the same denominator. Go to page 131. And on page 131 is a really cool thing here because this box right here will make your life easier. This is like the ultimate cheat codes for math. So in fact, this is so important that I want you to, on page 131 in your book, I want you to fold the corner down because you're going to want to look at this box many times. As in a lot of problems, you'll have 1/5 and you have to compare it to 3/5 or something like that. So if you just know that 1/5 is the same as 0.2, which is the same as 20%. These are all the same. 2/5, 0.4, and 40% all the same. And then these, you see how these have bars on them? 1/3 is the same as 0.33333, which is the same as 33.33333%. The bar means that that number repeats forever. So look back at this and it will make your life much easier. Okay, so now what we're going to do is some of the problems at the bottom of page 131. There's several of them here. We'll do a couple together and then you'll do the rest on your own and we'll check in. So let's look at problem E here, which is comparing 2/3 and 0.6. So you're comparing a fraction and a decimal. The best way to do this is to make these both be either fractions or decimals. So let's make them both be decimals, the same kind of number, and that makes it easier to compare. And so just like I said at the top of page 131, there's that cheat sheet. Let's look up there. So we want to turn 2/3 into a decimal. So if I come up here and look, here's 2/3 and it says it's 0.6 with a bar on it. And so 0.6 with a bar on it means that it is 0.66 and going on forever. So 2/3 is really the same as 0.66, and those sixes go on forever, but just 2 6s is enough right now to compare, because if I'm comparing 0.66 with 0.6 nothing, so I could put a 0 here, right? Because 0.6 is the same as 0.60. So now it looks like 66 compared to 60, so clearly this one is bigger. Got it? So why don't you try, I'll tell you what, you can skip F, don't do F, and why don't you try the rest of these on your own. Okay, so ready, go. All right, so for letter G, you should figure out that 1/5 so let's remember we even did 1/5 before. We did that a few times, right? So to turn a fraction into a decimal, it is 1.0, that's the 1, divided by 5. So that's a 0 point, and then 5 goes into 10 2 times. So this is the same as 0.2, and that's 0.2, so these are equal. All right, so if you did not do H, do H right now. Ready, go. Okay, so this you should remember, if you're turning a percent into a decimal, you just move this over 2 times to the left. So 42% is the same as 0.42, and 0.42 is less than 0.44. All right, if you've not done letter I, do letter I. Ready, go. All right, comparing 7/10 and 7%. So remember, 7% is the same as 7 over 100. Wow. And if I want to make this be over 100, this would be 70 over 100. Got it? So I turn them both into fractions. I couldn't put them both into percents. If I put them both into percent, that would be 7% versus 70%, right? So clearly 7 is less than 70. And if you have not done J, do J now. Ready, go. All right, so for this one, we could make them both percents or both decimals. Either way, it doesn't matter. Let's make them both be decimals. So remember, if you're changing a percent to a decimal, it's 2 spaces to the left, right? So the decimal's there. I go 1, 2, and look, I've got 6.50 compared to 6.5, which is the same thing. They're equal. Awesome. Okay, so let's go to the next page to guided practice, which is page 132. Please go to page 132. You're going to write in your book. Now, number 1, guess what? I did this one at the beginning of this Ed puzzle. I did this exact problem for you. So I would like you to do number 1 right now. Ready, go. All right, so you should have these in order as starting with
1/2 and 3/4, and then we have 4/5, and finally 9/10. Right? And if you remember,
right? And if you remember, we made it so they all had a denominator of 20 is how we figured this out, I think. And if you leave them as like the denominator of 20, that's okay too. All right, so now let's do number 3. This is the last one. We'll skip number 2 because, you know, I'm not so terrible. I make you do every little thing. So do number 3, and this says, the table shows the wins for some middle school football teams. Which team has the greatest fraction of wins? All right, so you're going to have to turn these all into either percents, fractions, or decimals. My tip is either percent or decimal is probably the easiest. Probably decimal is the easiest one, but you can do whichever you want. And then we have to figure out, remember, you always draw a box around what do you have to find out. We find out which team has the greatest fraction of wins, which means which of these is the biggest. So, ready, go. All right, so you should have figured out that if we're going to turn these all into decimals, 95% is 0.95. 9 over 10 is 0.9, which is the same as 0.90. And this is just 0.89. So which of these is the biggest? Eagles. The Eagles have landed. Cool. Okay, so that's it for the problems for today. We will do the independent practice tomorrow. But I just want to point out, if any of these problems you don't know how to do, like you were getting them wrong and you're not really sure what's going on, please go back and reread the examples in the book. I didn't go through every example on like exactly from the book during this video because I kind of explained them a different way. But if you're ever not sure, go back and look at the examples. They're really good and it will really show you how to do things. Got it? This is an important topic that's going to be really important for all the math we do all year long. So it's really important that you get this particular topic really well, comparing the different types of numbers. Okay, so have a great day and I hope you like my hair.